AWS announced its new European Sovereign Cloud offering. Apple debuts an autonomous agent for Xcode, and Codex drops a new desktop app to take on Cloud Code. NVIDIA announced a new AI platform, not a GPU this time, but a completely new 6-component platform. And we've got two new fresh models to talk about, Kimi 2.5 and Gemini Flash, both delivering strong price performance. So let's dive in.
Hey Stefan, good to see you. You're here, episode 2, Cloud Chronicles.
Yeah, and episode number 2. Looking forward to it. How are you doing?
I'm doing great. How is it on your side?
Well, yeah, a long day, but happy to talk about some interesting topics with you. So, should we dive in?
Let's go.
Cool. So, the first topic that we want to talk about is the AWS European Sovereign Cloud that was announced at the beginning of January. I mean, AWS announced it like 2 years ago, 3 years ago, and it took a long way, but now it is generally available for every customer out there. And if people ask like what is like this new cloud offering, I think we have to dive a little bit deeper into how AWS builds the whole infrastructure behind it. So AWS splits its infrastructure, so all the data centers, all the availability zones where the data centers reside, and the regions in so-called partitions. And partitions are logically and physically separate infrastructures for customers. We have a bunch of different partitions out there, like AWS has the AWS GovCloud, what is specifically for US customers. There is an AWS China partition, so a separate partition for China customers. And there are the commercial partition, and the commercial partition is the partition where most of the customers are in. And now the AWS ESC has launched, so the European Sovereign Cloud, what is, as I said, logically and physically separated from all the other regions that are out there. And there are a bunch of different features or specialities about the ESC. For example, it is a completely new parent company. So there is a new holding underneath where the ESC is operated from. And for example, in the commercial partition, so the normal regions, let's say, where AWS customers build their workloads on. And this ESC is completely operated by EU citizens. So all the people who are operating the data centers, all the people who are managing the European Sovereign Cloud have to be European citizens. And there are things where we have to say or tell the customers when we talk with them that the European Sovereign Cloud handles the data a little bit different. For example, the European Sovereign Cloud make sure that the metadata from our customers is not leaving the region where you deployed. This is a little bit different to the commercial regions because in the commercial partition, if you deploy your, let's say, your IAM, so your identity and access management workloads, there is a parent company, in the case of the commercial partitions, it's in the US, and the metadata can leave the region because we have so-called global services like IAM, where the data has to leave the metadata at least. And with metadata, I mean things like the resources, the policies, the roles, etc. And these have to leave the region. And this is different in the ESC. That means in the ESC, if you deploy your identity and access management, the data and also the metadata will never leave the region where you deployed in. Everything will stay in the European Union.
So, Stefan, what would you say in terms of how customers can now in the German market start using the ESC? Do you need a specific registration for it, or is it like any other AWS regions we have already known over the years?
So for customers, there is a special process how we can register or get access to European Sovereign Cloud. For us, as employees, there's also a special process. So it's not the regular process of getting access to a region, because you need to verify that you're a European citizen. So there are some nuances to this, how you can get access, just to make sure that it complies with the regulations and that we assured. So one thing that is also important to mention is the commercial partition and the regions within this commercial partition where most of the customers are in. AWS claims that this is sovereign by design, and it means that even in the commercial partition, customers don't have to be scared that employees from AWS get access to their data, or that like a foreign government can easily access the data. So this is something where AWS makes sure that this does not happen. So everything is encrypted in transit, everything within the commercial region, make sure that the data is not leaving the region. So not the metadata, but the data itself. So all of these things are things that are already applied in the commercial partition. It is more about the operating model here. And I think this is something that people have to be aware of. So in terms of operating, all the operations and management of the ESC happens within the European Union.
I think this sounds great. I mean, even with maybe not having the easiest access yet to it, so there are several processes that you have to follow and register, I think it's still a very optimistic sign for the European market, especially for companies like integration companies or software vendors who have already a huge stack on AWS. And if they have customers, for example, from the public sector, they still have the flexibility, like all the knowledge they have built around AWS, they can still use that and apply it to the new region and still fulfill the, let's say, strict requirements that public sector customers have. And I'm super curious about it. And I think this is going to be huge. And I'm really looking forward to the next months, where we are also going to see first releases then natively on the European Sovereign Cloud.
There's also some announcements. So we have initial services that are released for the European Sovereign Cloud. So not all services will be available from start. There are a lot of them still on the roadmap or will maybe not come at all. But then there's also what I see with customers very often, that they think about some kind of an active or active passive setup of deploying their workloads. Because many customers treat the ESC maybe not as their primary location, but as a failover state or as the region where they want to have, as I said, a backup in place. And there are things, and we released a blog post recently, a few days ago, about how you can build up a sovereign failover strategy. So having your workload still in the commercial partition, but then having some kind of a failover strategy, how you can fail over from one partition into the ESC. Because this is something that is not straightforward, because there is no native connection between partitions. All the partitions are connected to the internet, but there is no native connection between them. Because think about it, in the commercial partition, if you have two regions, you can easily connect them. You have IAM resources shared across all the regions. In the ESC, you can't use the IAM resources from the commercial partition, so you need a separate one. So how do you make sure that these workloads are authenticated across partitions? And all of these things are addressed in the blog post, and there will be more content coming in the future that addresses all of these nuances and how customers have to prepare for it.
I would say great call out. So we will also add the blog post down here, and you can check it out then later on in a calm moment. And one more thing that I also saw is now, and we had a X post from Andrej Karpathy and he was the person who actually made this term vibe coding. And now Andrej actually put on X that now we are in the field of agentic engineering. And we could kind of see that in end of last year, beginning this year, that there were more and more folks using the terminal, spinning up, for example, Cloud Code sessions, Hero CLI sessions, or other solutions similar to that. And then having multiple tabs opened, for example, via tmux, and then having these parallel sessions to create, for example, features in parallel. You could use GitHub work trees for that. So this was then the 1000x productive engineer or architect, but still we had only few folks who used that via the terminal. And now this is changing. So we have now more tools like the Codex desktop app or anti-gravity agent manager, or even we had now a big change now in Xcode. So it's, I think, version 26.3. And it sounds like just a minor upgrade, but this one is huge. So especially with Xcode, what happened there is that previously you had the chat experience. You could, like you had with vibe coding, create your Xcode code in there. But now this is also agentic native. So they have now a collaboration with Claude and as well with Codex from OpenAI and Anthropic. And they work together. So they thought about, okay, how can we make the token calls more efficient? How can we make sure that the tool calls are more efficient? And now the end user fully benefits from that. So when you open up Xcode, you have now an agentic experience where the agent is now building your iOS app. And you always have the preview also on the right side by Xcode. And I think with that now, the App Store might be flooded even more with new apps coming up. But especially for folks who have not yet their app ready or have their app ready and want now to ship features much faster, this is a great opportunity. And I'm pretty sure we're going to see now many more sophisticated features which were in the backlog of software vendor companies now going to be released just within the next months. And this is going to increase the competition even more. So a very exciting announcement.
What I found quite interesting is that Apple is now cooperating with the big LLM providers like OpenAI and Anthropic to use their agent and improve the token usage there. But they haven't decided to build their own agent here that acts within Xcode. So rather than, as they prefer, to use a partner for this. So they are quite late to the party, I would say. If you compare it, Kiro from AWS has the Kiro autonomous agent announced and is already in preview for 2 months now. Before that, of course, Claude Code and Codex already had their autonomous agents. Interesting, they finally jumped on the train for iOS developers. I think it's a big thing, a big announcement.
Yeah, I agree. I think Apple now seems to have unveiled their strategies. They always go now with a partner to bring in agentic features. And I think now also this rumor about the Gemini deal inside iOS becomes also more and more concrete. And I think at the end of the day, we also can interpret this as a pattern. So it becomes less important where the LLM is coming from, but what you actually build around it to provide the value. And this is something which we can also leverage for our software architectures, but still with a caveat to say we still should care about the LLMs, but maybe not focus that much that we have to build it ourselves or fine-tune it ourselves. I would say the fine-tuning especially is always a nice top-up. But until we get to the point where we really think about changing the LLM, there are so many other tasks we can do. And once they have a very high bar, then we can start thinking about, okay, fine-tuning LLM or even going that far to create our own LLM, which is becoming easier. I mean, we had last time the reinvent updates with the new AWS service, which helps you to get access to the Nova checkpoint so that you can continue the training there and save some bugs. But overall, I think it might be something that others are going to replicate more and more if Apple is now going such a bold move.
So I've tried now Cloud Code, Codex, desktop app also, and as many of us still coding in the IDE, I would say. So autonomous agents are not taking over all the work. But I think it's interesting to see if you start your coding projects in your IDE, with a chat agent, and it doesn't matter which LLM you use, but if you use it in Cursor or in Kiro or just normal VS Code, you still have to do the work of prompting, getting response and seeing how the agent fulfills a specific task. Kiro started with the spec-driven approach where you define the project that you want to build. And then it lists the tasks. It will guide you through the steps, also asking questions have you thought about this, or how should we build this? So it's a very detailed step-by-step guidance by Kiro. And I felt that now when I use Cloud Code, for example, or also the Codex desktop app, it's very similar to the spec-driven approach. So it is also acting very autonomously after you told it what to do. In Kiro, maybe this is a feedback also to the service teams, creates a lot of files underneath, an analysis file, or any other, a lot of artifacts during the deployment. Cloud Code is not doing this, and Codex also not. I have to say that if you code with Cloud Code, it's very impressive how the agent skims through you and analyzes your repository. But it feels like Codex is a little bit more precise in what it is doing. I mean, it's just a feeling from my side. I have to do a little bit more or put in a little bit more work to see how they differ. But they are all it's very, I use it very often if I want to have if I have either an existing project and I want to do something add a feature or tell the agent to maybe refactor my code. Cloud Code is very good in doing this, and Codex also. So I wouldn't use my IDE for this. I'm using an autonomous agent and then tell the agent to analyze my code, refactor it, maybe add a feature what I want to add, and then it does that automatically in the background. So it's really impressive to see how that works.
And also, yeah, to your point, so it's a coincidence that I have the Kiro hoodie today on. So the little ghost is here picking up. And I also have like the feeling that whenever you turn on the spec-driven mode in Kiro, it really thinks things through with this 3-step process and creates very large plans. So with that, what I also learned as a pattern is it really fits well when you have super large tasks, because where Kiro is great in is breaking a huge project into subtasks and then tracking them. And then you can also monitor like how each subtask is processed. With the other solutions, they tend to have a slimmer plan. And this makes you quite fast, but you still have the, the to-do from yourself to go back and check in with the agent. Here, Kiro is a little bit more convenient. So you can let it work really on a huge chunk of task. It can be like 20, 30, 40 tasks, and it's going to go through them, checkmark them. And I think both have their pros and cons. So with Kiro, you really then need to be aware what the scope is that you're putting out there. So if it's too big, you might lose the control. But if you really use it thought through, then you can automate a lot of tasks there and then just go through and then create your unit test or review the code. And it can help you to really become more productive. But I think you need to make a decision here.
So we're not using a new thumbnail for our episode, like the end of IDE. So I think like IDEs are still used for if you want to have like a detailed look into your repository. I mean, in the Codex desktop app, you can still see, of course, your repository and your code. But I think if you want to have like a more detailed approach about like working with your code, I would still use an IDE, right? So I wouldn't use an autonomous agent if I'm completely new to a repository or a project that I haven't used before. I would use an IDE and analyze it within the IDE rather than using an autonomous agent like Cloud Code or the Codex desktop app.
Absolutely. I think it's always great to start with this agent-only mode or autonomous agent mode. But at some point, you really need to go back and check the code because you can't like just let it do everything. And at some point, it will turn into gambling because these models will do mistakes. They still do a lot of mistakes. And sometimes also they forget things. So even if they are getting better with the context engineering, at some point, they're going to forget several files. And then the errors will come up. And if you don't scan the code, then there is a huge risk that you have introduced new bugs. So yeah, there are also countermeasures. I mean, you could build agents to review your code or look for bugs. These are, I think, also good patterns. But still, we shouldn't use the human in the loop here when it comes to software engineering. I always try to see when this might disappear. But I think it's still too early to really don't look into the code. I personally don't write code anymore myself, like hands-on putting in the code, maybe from time to time, just small details. So I let the agent create the code, but then go back and then review and try to see what are the patterns here. And then from time to time, you see, sometimes you ask for a specific way to implement it and it does the opposite. And then here you have to have your gotcha moments and then go back to the agent and tell it, hey, we're not there yet.
Perfect. So then
all right,
let's jump into the next.
Yes, let's do the next one. Do you want me to do the model updates?
Oh yeah, sure. Let's do the model updates.
Yeah, so there have been two very important model updates, especially from the open source field. The first one is the Kimi 2.5. And this one is very interesting because it's a 1 trillion size in terms of parameters. And they are using a mixture of expert architecture. And with that, when the model is activated, you're just using 32 billion of the parameters. So it's very efficient. And when we look at with which type of models this can be compared, it's actually in the league of the top tier models. And this is huge. So you kind of can put it into the space of like GPT 5.2, Gemini 3 Pro, or even Cloud Opus 4.5, or even in the 4.6. It might not always be better than them, but it's really close to it. And then if you look at the price point of this model, it is around 78 or 80% cheaper than Cloud Opus. And that's massive. So you really cut down the cost. You have a very fast model, very cheap model. And now what we can see is the Kimi is also available as a consumer product. So they have the coding agent. They have also the normal user agent where you can upload your files and chat with it. And there we can see they are now promoting the agent swarm pattern. And why is that now happening? So, for us, Agent Swarm is not a new pattern. So we saw that, for example, in Strands, and you could do it for a very long time. But what is new here now, as they know that this model is very high in terms of reasoning, but still very cheap and fast, now you can put out these Agent Swarms and it won't be that expensive, because before you had to be really cautious about like if you deploy your agent swarms, but now they are just promoting it and putting into the hands of simple business users. So now simple business users can put out their agent swarms. And I think this is a huge announcement, and will definitely will make now in 26 agent swarm a very important pattern to build your agentic architecture.
And it's now like the third model from China, right? Like from Chinese companies, it's now the third large open weight model that exists out there. So there is quite a competition now coming from China, competing with US companies, bringing out the best models. So after DeepSeek, I think version 3, I think version 4 is expected in the upcoming future. DeepSeek was also in some regards groundbreaking, because it was saving so many resources and introduced this mixture of experts model. And what I also heard is that and maybe you can elaborate a little bit deeper into this, like this agents from idea. It's like, I think it introduced now a new capability of parallel agent reinforcement learning. So it prevents now that the serial collapse where orchestrators default to a single agent execution. So I think this will also be something where the quality and the overall quality will improve now from these agent swarms.
Yeah, very good point. I think now we see this dynamic of, on the one side, we have the model providers who really focus on, increasing the ceiling in terms of reasoning. So on the other side, we have the Chinese model builders who also very much are focused on the efficiency side of things. And I mean, it's really cool. It's a great dynamics. We need competition there, and we can see the overall field is benefiting from it. And we are also now seeing the model prices going down and down. And yeah, with the agents farm architecture, it is really about that these agents run in parallel. So this is really important. And what they do is they can interact with each other, and they can also share memory with each other. So one agent can focus on, for example, research. The other agent can focus on creating code snippets. Another agent can focus on creating a unit test. Another agent can focus on marketing. Another one can focus on the testing and so on. Another one on the operations. So you can see you can now build software development teams out of that as a unit, and you have these swarm of agents working together. I also saw now Anthropic is building that as well inside Claude Code. So with that, I think now it's really becoming official. So I think in a few months, agent swarm won't be a big deal anymore, and now we're now seeing it flourishing as an important pattern.
I think it goes into the same direction as if you look now in the desktop app from Codex, we also have now multiple agents that can act in a single work tree. I think you tested it out and you said it worked so but I think it is this is coming up more and more. This will also be released by other providers, that multiple agents can interact with each other simultaneously, share memory with each other to work on a project together.
Yeah, so what I did is 2 experiments. So once I tried it out with Claude Code in a CLI and used work trees to separate the agents. And there it really happened that one agent jumped into the work tree of the other one. And this made it a little bit hard then to fix it again. With Codex, now it looks more stable. Codex gives you really the chance to select the work tree inside their IDE, or better to say inside the UI, because here we come also again to the term. So it isn't an IDE anymore. It's like an agentic editor. And yeah, there you can select the work trees, and it now seems to be much more stable there. So I think this is also a second pattern, definitely working now in the same feature branch, but in multiple work trees. Yeah, definitely going to be also the status quo now in the coming weeks.
Yeah, and last thing to say, Agent Swarm is in beta, but will be GA, I assume, pretty soon. So the next topic that I have is AI related, but not AI related. It's about OpenAI, who released a technical disclosure about how they handle the workload of 800 million users coming in daily for ChatGPT. And
wow.
they published this technical disclosure and focused on how they handle the database workloads underneath and how they scale, in particular, their PostgreSQL database. Because there is some interesting nuances to this that we should share with the people. It's that if you think about the workload itself, 800 million users per day that they have to handle, they still use a single PostgreSQL writer instance and 50 read replicas across the world. So these are deployed on Azure, and they have millions of queries per second and have to maintain a low single-digit millisecond latency. And in this technical disclosure, and I have to admit, I read through the first pages and then I used Notebook LLM to explain to me what exactly are the special things about this deployment, because it's a pretty long technical disclosure. So one interesting thing is that they limited the sharding of their database to specific workloads rather than sharding the whole core database. So sharding, for those of you who are not aware, is like splitting a large data set into smaller chunks. So smaller independent chunks, and then you spread these chunks of data across multiple PostgreSQL servers. So instead of keeping everything in one big database. But this also comes with challenges around keeping them in sync. There's additional overhead in managing all such a sharded database. So the architecture behind the OpenAI deployment is that they use a single primary writer instance with 50 read replicas, as I said. And then they offload the write traffic of the database. So they tweaked some part of the architecture. Mm-hmm. For example, they offload the write traffic that they have, not to their PostgreSQL database, but to Azure Cosmos DB, what is like a NoSQL database. So on AWS, it would be a DynamoDB. And that means that they no longer allow new tables to be added to the primary PostgreSQL database, but they are defaulting new workloads to the sharded system, so to the Cosmos DB. Mm-hmm. Then secondly, they have like a very advanced caching mechanism in place. So there is like a locking and leasing mechanism. When a cache key is missing, only one request will be sent to the primary database, while the other request will wait until the single request updates the cache again. So you don't have a huge amount of cache misses on your primary database. The third thing is, in order to avoid noisy neighbors, they try to isolate these workloads. So they have like a tiering model where they have like a low priority tier database and a high priority tier database. And they route these workloads depending on the tier where they're in. And the last thing is that OpenAI decided to avoid multi-table joins on their SQL database. So rather than doing the joins on the database layer, so combining different tables together to get the results, or doing the table joins on the application layer. So that also offloads the work from the database.
Wow, this is impressive, and also shows us like even at scale, there are several patterns which really look simple at the beginning, right? Like with just one writing instance and then 50 read replicas. And what I found also interesting is now that they are, so if I got it correctly, they're offloading their write pattern to the more and more to the Cosmos DB. So their goal is like to kind of migrate more and more to the Cosmos DB, or how do you understand this?
I think it's not about migrating to the Cosmos DB to a NoSQL database. I think they're keeping their PostgreSQL database for read workloads. And if they want to introduce, or let's say there is a write intensive workload, like introducing a new feature or something, they first deploy this on DynamoDB and test it on DynamoDB, or any other write-intensive workload will be offloaded directly to Cosmos DB. I'm not sure how they want to behave in the future, so how this is then deployed on their PostgreSQL database. But as of now, it's pretty interesting to see how they handle this globally.
All right, I see. So for new workloads, they're preferring the NoSQL approach. This is like the gist of it, right?
Exactly.
All right, man, that's great. That's so fantastic, like to get these at scale stories. I think we should do it now more often.
Yeah, I think so too. I love reading these technical disclosures to get also insights in how these companies handle millions of users. It's really impressive. It's also every year when we have Prime Day, I love to read through how DynamoDB and like how AWS handles all like the million and billion requests from users using AWS services.
Yeah, absolutely. We can also put in these blog posts down there, and then you can also see like how many nodes are just spun up to call Bedrock or how many tokens were consumed. So it's a lot. And speaking about Bedrock, there were also a few updates about agentic capabilities natively baked into it. So one of them is prompt caching. What you can do inside Bedrock is you can turn on prompt caching. And with that, for example, think of your system prompt. If it should be repeated in calling the model, you can store this inside the memory of the model itself. And with that, you can save latency and also cost. Now, this was bound just up to 5 minutes. So you could memorize it just up until these 5 minutes, but now you can go up to 1 hour. So this is massive. So now you can really memorize, for example, your system prompt or, for example, tool descriptions. So now in the agentic world, the tool descriptions also tend to be quite long, and a cost factor and latency factor. You can put it into a 1 hour time box. So this is really great. And currently this is supported for cloud models inside Bedrock, and you can also now test it. I think this makes a huge difference. Then another one is completely a new framework, you could say, or a new pattern. So now you have server-side tool calling inside Bedrock. What does it mean? So what it means is that in this case, typically what you have when you build your agentic architecture, you have your orchestrator, for example, running on your container solution like EKS, ECS, or for example, Lambda. And then you have like your LLM hosting solution like Bedrock, where you can call the LLM via a serverless API. And then whenever the LLM tells the orchestrator, hey, there is a tool I want to call because I want to know what the weather currently is, then the orchestrator needs to call another function. Now with server-side calling, everything can happen without the orchestrator needed to do the tool call. So Bedrock directly can call the tool itself. So what you can do is there are several native functions directly which you can turn on. Or what you can also do is you can define a Lambda function, and then Bedrock calls the tool via the Lambda function directly. So you don't need a intermediary orchestrator. Now, there are also several prerequisites to it. Currently, this is only supported for the OpenAI open source models inside Bedrock. So this is a limitation, but I think this brings in a new, fresh perspective. So it shows us there are ways also to simplify the architecture where actually the Gen AI service takes care of the orchestration, and then you just need to think about your tool definition.
I'm also quite interested whether this has any impact on the latency. So whether you save any latency if you avoid calling the orchestrator all the time.
Absolutely. I can imagine there will be a huge impact, and this is something we can also experiment maybe. And then in the next episode also share like what we have found out.
So now let's go down a little bit into the infrastructure layer, because NVIDIA announced in early January its Vera Rubin platform. And I think this is worth to talk about, because this Vera Rubin platform is now a fully fledged 6-component infrastructure, AI platform infrastructure that addresses certain changes in the AI world in the last years. Because this Rubin platform addresses the point that we are shifting a little bit from the training first approach to the inference first approach. So the platform that NVIDIA previously had was the Blackwell platform. And the Blackwell platform was a platform that was focusing on training models. So it was focusing on maximum training throughput. So big models, big clusters, and peak flops. And for inference, this is not necessary. So that's why NVIDIA announced the Rubin platform. So previously, if we had like dense models, like huge models where every parameter is used and every token is used to generate a response, we went a little bit more into the mixture of experts architecture. And famous models of mixture of experts is, for example, DeepSeek or Kimi 2.5 thinking. And for these models, when you send a request, not all the parameters are executed or used for generating a response, only a subset of it. But you need to make sure that your GPUs underneath are supporting the mixture of experts architecture. And then think about it, if you have multiple mixture of experts, so many small models that are generating a response, you need to somehow make sure that the GPUs underneath need to communicate with each other, where you need some kind of a networking in place. You need to have a synchronization in place. So this is a fundamentally different approach in building GPUs or handling this workload in general. And NVIDIA addresses this with the Vera Rubin platform. So a complete platform for handling and addressing this mixture of experts approach, where inference is the key or primary driver and primary cost driver also of the future. So it's not like a one-time training first approach that generates the cost, but like the continuous inference of models will drive the cost in the future.
Wow. I think whenever these types of announcements happen, this is like a big shift in the industry. And I think like we now saw like the model efficiency improvements, and now with this under the hood, I think like AI latency and pricing at some point will be so much so we won't even need to think about it anymore.
Yes, and NVIDIA claims that they're saying training is no longer the center of gravity, inference is. And also the CEO said like inference is now a thinking process and not a one-shot answer.
Yeah, absolutely. And maybe like one last point from my side, what I also saw is in the open source field with the Gemma model. So Google is like pushing a lot with the Gemma family. And by the way, Gemma models are also available on Bedrock. So if you want to have an easy start, if you're already in the AWS world, you can find them there as well. And there is now the new Gemma 3 Flash. And this one is also like in terms of model size, quite compact. I think it's available up to 27 billion size in terms of parameters. But this one is amazing if you have like document processing workloads. Why is it so special when it comes to document processing? In this case, what they did is they added some agentic capabilities natively into this one. So whenever you send documents or images to it, it knows to create Python code for these types of tasks. For example, to annotate parts of the image. Think of you have an image of a street scenario. It will annotate, okay, there are the passengers, there are the cars, or maybe a hidden area where when you just have a quick glimpse on it, you wouldn't see that something is happening in the background. And now with this annotation first strategy, it can like show areas where the model should pay more attention to. So with that, you can increase the quality. And also it can like do day-to-day tasks for analytics of images, like cropping the image, rotating the image. And with that, it becomes much more easier in your application because you don't need to add these steps first, or like even resizing the image. The ones of you who have worked with invoices will know sometimes invoices can be super long. So now you need to have like an image editing pipeline first, maybe cropping the image or cutting it into chunks, and then give it to the LLM. And these types of things Gemma Flash can do out of the box. So very impressive. But now to make the point connected to Kimi, in terms of pricing, this one is close to the Kimi model. But the Kimi model brings in like the additional agentic and reasoning capabilities close to the frontier models. And now we can see like this multi-model strategy becomes more and more important this year because certain models have such tangible characteristics that we can now really test them out and be very conscious about, okay, I picked this one for my image processing. I picked this one for my agentic swarm. Maybe I picked the Opus one or the Gemini 3 Pro for very specific agent capabilities, maybe for my main supervisor agents. And yeah, with that, I think we had a super packed episode here. So episode 2, as always, it was a very well spent half an hour. Potentially we had a few more minutes today, but I think it was definitely worth it. And also big shout out, Stefan, for bringing in the OpenAI story on how they are defining their database strategy and also how it's evolving over time. So first starting with a relational database strategy and now also introducing these NoSQL patterns. I found that super insightful.
Thanks, Buria. Then see you next time for episode 3.
Yeah, see you next time. Have a good one until then.
Bye-bye.
Cheers.